And here we are in our final part of atmospheric pollution. This is really just the very last topic on acid deposition. So here we go. And your essential knowledge, as per usual. All right, so acid deposition is a fancy way, right, of saying acid rain. But the thing is that acid rain doesn't really cut it because you can have acid deposit through rain, acid rain, or some sort of precipitation like snow or fog or something like that. And then there's also dry deposition, which are like acidic salts that get deposited out of the atmosphere. So, you know, acid deposition, because acid is getting deposited in some way. But basically, the sulfur dioxide and nitrogen oxides are actually producing acidic chemicals by reacting with the water in the atmosphere. So if you look at sulfur dioxide and water, you get sulfuric acid. Not good. Or nitrogen dioxide and water, you get nitric acid. So you have these acidic compounds that are being formed as secondary pollutants. And really, when we talk about acid deposition, I want you guys to really keep in mind about sulfur dioxide being emitted by coal power plants, because that is the primary way that you get to acid deposition through the emission of sulfur dioxide from coal power plants. But, nitrogen oxides are definitely out there too. They come from coal power plants too. Also motor vehicle exhaust, as we learned before, and photochemical smog. La la la. Okay. Anyway, it can occur over lots of days and travel long distances before being washed out in the air. So, like where the primary pollutant is actually being emitted, the secondary pollutant, the deposition of the secondary pollutant isn't going to happen until it's further away, right? Really downwind of where the primary pollutant came from. And so, right, acid rain is considered a pH of less than 5.6. So anything above 5.6 really isn't acid rain. Right, natural rainfall is actually slightly acidic anyway. So, like I said before, there are really two kinds. There's wet deposition, where we talk about precipitation, that rain, snow, fog, and then dry deposition, which are those acidic salts that are formed. And so, wet deposition takes place in more distant downwind areas because they're lighter, and so they can travel farther. Whereas if you think of dry deposition, or like actual like acidic salts, they're falling out faster. So, and also closer to the source because they're heavy. And if you look at this beautiful diagram, hopefully that can show you something that I wasn't able to explain in words. So here is a map of the United States, and these red dots indicate major coal burning power plants, and you can see that really, right, the more east we are, the more acidic that acid rain is. And so, why is there acid rain in Connecticut and Maine, right, or Vermont even, or upstate New York, when there really aren't that many coal burning power plants? Like I said before, right, you are downwind is where you're really going to see the effects. And right, the Northeast is downwind of, middle America, the Ohio, Indiana, right, those places where you have a lot of coal burning power plants. And so if you think about the prevailing winds where we are the westerlies, and so they are blowing in from the west and they are blowing towards the northeast. And, right, so all of that pollution gets blown in that direction. And by the time the secondary pollutants fall out, right, it's far away from the primary source. So beyond just, where you are located, also there are geologic differences in where you are and how acid rain will actually affect the environment, because different soils and different bedrocks have different compositions. And if that underlying bedrock has some sort of buffering material like limestone, the the acid gets taken up by these minerals, and the excess acid it doesn't increase the pH of the surrounding area. Whereas in certain areas that don't have this buffering capacity, when that acid deposition happens, right, the pH of the surrounding soil and waters actually raise, and you can have some, detrimental effects, as we're about to see. So, aquatic ecosystems are devastated by acid deposition. So, the ocean is kind of too big. Well, when we get to climate change, we'll talk about ocean acidification, but it's not from acid rain. So let's remember, right, that we're talking about acid deposition, not carbon dioxide going into the ocean. So we're not talking about the ocean here on this aquatic ecosystems. It's more enclosed in smaller systems like lakes and streams. And so, right, when acid deposits into lakes and streams, it lowers the pH like directly, because that's happening. And if the pH gets too low, then you can get some pretty serious developmental and reproductive issues. And below a pH of 5, most aquatic organisms or amphibians can't survive. So if you look at these salamander eggs in this picture, right, at a normal pH, it's a little baby salamander. But on the right, you have a pH of 5, and you just have, not good development happening there. So another thing that happens in lower pHs, whether it's in water or in soils, with decreased pH, you have more available metals. So those metals that are available are bioavailable, meaning that organisms can take them up. So they become unbound to the sediment in low pH, and organisms can take them up a lot easier. And so that's where you get these heavy metals like aluminum and iron, mercury, lead. And so those can really impair physiological functions of organisms. So, what are the direct effects on plant life? So like I said before, right, because these toxic metal ions are released, right, they're taken up into their tissues, and that is not good for even plant life. But also certain essential plant nutrients get leached from the soil, so they come out of that soil horizon and they actually leach out of the soil, and they're not available to the plants. So not only do they have the nutrients that they need, they now have these extra heavy metals. And it could kill the crop outright, or it just reduces productivity, reduces growth, and then the trees, right? Trees are a little more hardy than crops, let's say, but they're more vulnerable to stress if they don't have what they need because of this issue through acid deposition. Any drought or disease or anything like that, those kinds of stressors, they are less tolerant to those. And so, mountaintop forests are actually really susceptible because their soils are so thin, and they have fog that covers them all the time, they can actually be really susceptible to acid deposition. And finally, what are the effects of on humans? Actually, nothing other than our structures get dissolved. So, like any kind of statues or monuments, if you look at a cemetery, right, marble and limestone, all of those will break down with those hydrogen ions from acid rain, and ultimately, right, they wear down, and that's not good for us. But like physiologically, other than that, there's nothing, right? So there you go. That is air pollution, and I hope you somewhat enjoyed it. Okay.